Hi, I'm Gia, and this is the video for my creative project. My idea is to write 3 math problems ranging from early AMC 10 to mid AMC 10 level in difficulty. Each of them will have a different theme, and I spun a wheel to choose 3 themes. And the themes are Sandy the Sloth, random combinatorics, and join regular polygons. After I write the problems, I'll present a solution to the one I like the best and include a PDF with all the problems and their solutions. So this is the problem I chose to present for my project. So take a minute to read the problem, and now and pause the video, and now I'll be presenting the solution. So what we can do is split this into 2 cases, where the first case is if the 5s are distributed to different people, and the second case is if the same person has the 5s. So if the 5s are distributed to different people, then since the rest of the numbers are even, the sum here must be odd, and the second player must also have an odd sum, and the third player must have an even sum. So if 2 players' sums are odd and the third player's sum is even, then all of them will know which ones have a 5 based on which 2 sums are odd. So now the second case is if the same player has the 2 5s. And the rest of the numbers are even. So this means that all of the sums must be even. So now the only way that all of them won't be able to tell which player has the 2 5s is if another player has a sum of 10, and the only way that could happen is if a player has 2 and an 8. So the other one must have a 4 and a 4. So now we could just find the probability that one player has a 5 and a 5, the other has a 2 and an 8, and the third has a 4 and 4, and subtract that from 1, because this is the complement of what we want. So the probability that one person gets 2 5s is first, the 5 is given to one person, and then there are 5 other spots left. So the second 5 has a 1/5 probability of going with the first 5. So after that 5 is put here, the other numbers are 2, 4, 4, and 8. And since we want the 2 to pair up with the 8, first we can put the 2 anywhere, for example here. And then the 8 has a 1/3 probability of going with the 2. So, and then after that, we have the 2 4s left, and they will go in the remaining spots. So the probability we have is 1/15. And since this is the complement of what we're looking for, our answer is 1 minus 1/15, which is 14/15. Yeah, so that's the answer, and the 3 problems and their solutions are linked in under the YouTube video.